is going to be on HAProxy's dynamic capabilities, mostly focusing on our Runtime API. Our presenter today is Nenad Mrdjanovic. He's our product manager here at HAProxy, focusing on the HAProxy Enterprise Edition, primarily on security. And Nenad's going to get going in just a second here. First, let me tell you a little bit about the question and answer part. Basically, you're going to be typing in your questions into the GoToWebinar widget there on the side throughout the presentation. We'll try to answer any that come up during the demo, because we're going to be doing a combination of slides and demo of the actual Runtime API here. So if you have any specific questions about the demo itself, try to ask those in real time, and I'll try to pose those to Nenad. And we'll end with some more Q&A at the end of the session. So if you have anything that you want answered that didn't get answered during the presentation, we'll try to get to it then. All right, with that, I'm going to hand things over to Nenad to get started on the presentation. Thanks.
Okay, thank you, Tim. So as Tim mentioned, my name is Nenad. I'm currently a product manager for HAProxy Technologies. Formerly, I was a senior solutions architect, and basically this is what I've learned in the combination of these two roles in the field and as a product manager of what a dynamic load balancer or an application delivery controller should look like in the period we currently work in. So to start off, sorry about that. Okay, works. Okay, so to start off, we're going to focus on the main aspect of how HAProxy operates dynamically. And this aspect is something that we call the Runtime API. So the Runtime API, or as some of you may historically know it as a stat socket, is a non-RESTful API, which we're hoping to change very soon with what I'm going to introduce a bit later. So it's an API that does not conform to any REST standards, but still it's an API that allows you to dynamically change the behavior of your application delivery controller. By dynamically, we mean it does not require you to reload the load balancer. It does not require you to issue some kind of a reload that would read the configuration. It does not rely on the configuration at all. It operates fully dynamically during runtime and instantly changes the behavior. You can access it two ways, basically. One is over a TCP socket, and the other one is over a Unix domain socket. A lot of people choose the latter because simply it's more secure. You can keep it local, and if your agent, which is a tool which will dynamically change the behavior, operates locally on the box that is running the load balancer itself, then there is no reason to expose this over TCP. On the other hand, if you have some kind of external tooling, if you have a central place that's going to issue commands over multiple load balancers, or maybe hundreds or thousands of them, then it is very convenient, of course, to have it listen on a TCP socket and accept connections only from trusted sources, which is something that you can obviously configure with HAProxy or with a firewall. The important aspect to mention with the Runtime API is that it does not ever touch the configuration file. So as HAProxy runs due to some security concerns, due to performance concerns, HAProxy will never touch the disk or any file on the file system. So as we'll see later, there is something that we as a company are working on that's going to allow you to use both, basically use the Runtime API and edit the configuration file. But if you're using the community version now, or you're even trying to implement something yourself, you can always do something with like a templating engine that would edit the configuration file as the Runtime API issues commands to HAProxy to change dynamically. So as an example, what can we do with the Runtime API? There's a vast number of things that actually it can perform. It's not just changing stuff, it's also getting information, it's also reading some internal states of HAProxy. It's also very useful in troubleshooting, as we'll see later. But most people focus on what it can edit. So server ports and IPs. So this is, as we'll see, this is useful for you to auto-scale your cluster. This is useful for migrating machines between hosts that are changing IPs. This is useful in a number of cases. It's also able to edit server weight. So the weight of the server basically represents how often it's going to get requests compared to the other servers in the same backend. Backend is HAProxy's terminology of something that more commonly is known as a server pool. We can also edit the server operational state, which is if it's ready to accept traffic, if we should drain traffic from it, it should be put to full maintenance mode. We can even also force the server to go down and have health checks recheck if it should be brought back to life. We can change the FQDN, which allows you to change the name resolution of the server. So if you're using HAProxy's resolvers, then it may be useful to change the domain name that you allow the resolver to recheck if maybe it should start with a completely different pool of servers, or just this server changed an IP and the name as well. You can edit server checks, and there's a lot more things you can do, but we'll go through some of them that are most useful and that you will probably use in your environment. There is also one other thing worth mentioning is that, as we explained the template engine and having the configuration API merged with the runtime API, there is also something that we call the state file. The state file is a file that resides on the file system, which is read by HAProxy during startup to populate some of this information back into the internal structures of HAProxy. What does this mean? So the runtime API, as we explained, does not change anything in the configuration. So whatever you edit in the runtime will apply immediately, but will also disappear if you reload your HAProxy instance. Obviously, this is something that we want to avoid in cases where your orchestrator or some external tool would actually populate all the servers from an external source. If you were to populate all the servers from an API, from something like console or something else, then a reload would wipe all the servers, and you would actually have a period where your traffic was going nowhere because no servers were defined statically in the configuration file. So the state file is what we write to before we reload the process, and then the state file is read when the process is loaded. The state file contains all the servers, their states, their ports, IPs, weights, and everything that HAProxy needs to rebuild its internal structures to be the same as they were before the reload. This allows you to basically have information stored between the reloads of whatever was done in terms of servers through the runtime API. And now this is something that's getting built, so this is not available yet. It's something that we call the unified API. So I explained the runtime API. We also, in the enterprise version, have the configuration API module. The configuration API module allows you to modify the configuration and issue reloads using RESTful calls. So the configuration API is currently RESTful, and it's also transaction-based, so you can actually issue a transaction start, then do a bunch of changes to the configuration, issue a commit. At the commit point, the configuration API will rewrite the configuration as you instructed it to do and reload the process. This is very convenient, but obviously comes with the drawback of having to reload to do configuration changes. Even though HAProxy supports hitless reloads, it does have some drawbacks in terms of statistics losses or any other similar information that can be stored only during runtime. So what the unified API will do is it will combine both. So you will get a full RESTful API that's going to perform changes through runtime for all the changes that can be done through runtime, and at the same time edit the configuration file to reflect these changes, but not actually reload HAProxy. This way, the unified API will manage both the running and the stored configuration. And of course, there'll be cases where you're not able to do something to runtime due to various constraints, and then it will behave as the configuration API behaves today. One other aspect of how HAProxy is dynamic is something that we call the LB update module, which comes with our enterprise suite. So the LB update module is a simple module that allows you to manage access control lists or maps, which we'll see later, from a central place. It works by having HAProxy poll a central server, which is a web server of any kind, so it can be a simple web server, whatever you're using today in your infrastructure. And it looks for a specific file that contains an ACL or a map, and then it downloads this file, it checks it, validates the file, and uses it to dynamically update the internal structures during runtime. So as we explained before, you can have a toolset or an orchestrator that sits outside of HAProxy and manages hundreds or thousands of these HAProxy instances. What it would have to do is it would have to connect to each and every one of them to issue a few commands to edit the map file. While this is technically possible, it's also very inconvenient in case you have, one of the boxes down, or you have one of the data centers unavailable. Is that you have to queue all these updates, and you have to worry and implement this retry logic and everything else in your toolkit, which basically can be replaced by this module. So the module will ensure that once HAProxy starts, even if it was unavailable, it will download this map file on start and start using it immediately. So all your toolset needs to do is make sure that the ACL or map file on the web server host is up to date to whatever you want it to be. The poll interval at which HAProxy polls this web server is fully configurable, and you can also force an update through the Runtime API. So now we're going to go through some basic operations on the Runtime API. So the Runtime API can run in both interactive and non-interactive modes. We'll see what this means later. It also has a built-in help that shows all available commands that can be executed. So while there is documentation on all the commands available on the website, there's also built-in help that you can use to help yourself while you're doing it without actually going out of your shell and looking around the web to find what you need. Some more basic operations include getting general information about the running process. So this general information will tell you which version you're running, how long it's been up, how much CPU is it using, how much connections per second it is getting, how much SSL transactions per second it's performing. And basically general information. There's nothing too detailed there, but it gives you a good overview of health of your load balancer. Then there's a lot more information available from the statistics for each front and back end server. So you can get information per server, how many sessions are currently active on the server, how many sessions per second it is getting, how many bytes of data it has sent, how many bytes of data it has received. Each and every one of those statistics and much more is available for each server, grouped for each backend and for each frontend. This data can be reported using CSV or JSON. We may be implementing some more output formats. If you have some good use cases for another format, feel free to send a mail to our mailing list. We usually try to accommodate community needs, and we want to make sure that people have the format they use commonly with other tools. Okay. So let's go over actually a short demo right here. So I'm going to switch to my HAProxy box. I hope that this is as visible as it is to me. And we'll do a short look at the configuration. So what we call the Runtime API is actually what was historically called a stat socket. This, as you can see, is a Unix domain socket. It resides in run HAProxy admin.sock. This is a file system mode, and this is what level of access it provides. So let's connect to this socket. This is what we call the interactive mode. So here I'll just set a longer timeout so we don't get disconnected while I talk. So here you can just type help and get all the information and all the commands that you can execute over the socket. So we'll go through the most common ones, and I'll show you how they're used, how people actually make all the changes that we're describing. But let's go over something that we already talked about, and that is getting general information about the running HAProxy process. So if you type show info, you will get general information. So you will see that here that you're running HAProxy version 181, release date is a couple of days ago. There is only one process. You're connected to the first process. This is process ID, and there's then a bunch of information about the pool sizes, the environment information. Then there's information about how many connections you have currently, how many of them are SSL, what is the connection rate, the session rate, the SSL rate. And you can see here that it basically does nothing. This is just the name of the process. So this is getting very general, high-level information about your HAProxy. Here, if you see very high numbers in SSL rate, or you see very low idle percent, you can quickly gather a general feeling about how your HAProxy process is behaving or why you're having issues. Then if we go deeper into detailed stats, sorry about that. So here, as this is a CSV format, you will see that you have a header that tells you all the information about every backend, every frontend, and every server in your configuration. So here you will see we have 5 web servers defined, 4 backends that's called demo address change. So all this information is documented, and all this information can be extracted using very simple CLI tooling like cut or using awk or any text processing tool. This information is usually used by other tools like collectd or Telegraph to actually gather information from HAProxy and ship it to an external tool for graphing, for analysis, or anything else that you might be using in your environment. So going back, let's actually do some API calls. Let's actually change something. So changing the server's parameters. So we can change the server IP and port, and this allows you to easily change which servers are available, how many of them you have, which of them should be accessed, and anything else that the client might need. This feature is usually combined with something we call as server templates. Server template is just a feature that allows you to define a number of so-called slots for your servers, where an external tool will actually populate the IPs and ports based on your orchestrator can do that. You can write a custom tool that pulls any API like Kubernetes API or AWS API to get information about how many servers you have currently running in the pool, and then HAProxy will, using this tool, dynamically follow upscaling and downscaling of your infrastructure. What the Runtime API also allows you to do is to dynamically change server's weight as well, which can where you can then dynamically change the request distribution between your servers. So this is useful if you have an external tool that monitors the load of the servers and then switches server weights around in a way where the server that has less load will start getting more requests in order to ease the load on another server that's maybe performing some heavier computations and is more loaded than this one. So going back, I'll just quickly go through the configuration. So we have pretty basic standard configuration. So this is the important part for this demo. So we have bound HAProxy to port 80 on localhost, and we have defined a server template with 5 web servers. So 1 to 5 is the number of slots that listen on a non-existent IP and port. They're also all disabled. So if we look at the status page, we'll see that this configuration, when running, generates 5 slots for web servers. they're all disabled in this backend. So what we have here is we have two Python web servers. One is running on .2 address and the one is running on .3. So we will see that if we request a site from the second one, we get, sorry, for the first one, this is number 1, this is number 2, right? So what we want to do is we want to direct HAProxy, we want to direct this backend to these web servers. So how this works is that you simply echo set server, then the backend name, then the name of the server, and you want to change its address to the first web server, port 80. And then you send this to the runtime socket. The runtime socket tells you that you have changed the IP from the old one, which is in the configuration file, to the new one, and the port changed from 9999 to 80. So if we refresh this page, anything, because the process is still in maintenance. The server is still in maintenance. So what we want to do is we want to set the server as healthy. As you can see now, the web server 1 changes state to healthy, and we can see that the check is passing successfully. So now, if we target HAProxy, we'll always get 1. So now let's activate the second server as well. So we will change web server 2 to 3, and we will change the state of web server 2 to ready. Here we see that the web server 2 just became ready with the address of the second Python process. So we now see that using round robin, which is the default load balancing algorithm of HAProxy, we switch between web server 1 and web server 2. So this is a very simple example of how you can, during runtime, scale up and scale down your servers. So you can have Kubernetes, or you can have any orchestrator. You can spin up instances, and then having a tool that pulls a central place, like either its API or something like console, and then executes these commands over the socket to dynamically change the behavior of your load balancer. So, and now if we do show stat, we'll see that web server 1 is up, web server 2 is also up, okay? While web server 3 and 4 and 5 remain in the maintenance state, as we see here. Now, if we do this, we'll see that the weight of the web server 2 has up to 70. So in theory, we should see much more of 2 than of 1 as we do now. So this is the example of changing the weight of your server in the backend to move more of traffic, more sessions, more rates to one web server or to a bunch of them, instead of actually having it equally distributed across all of them. I'm sorry, this. So we have shown this, and we have explained how it works. Is that you will set the server state to ready when it's ready to receive traffic. But for example, you can have an automated system that deploys code. So your CI can actually pull the server out of maintenance by simply pull the server out of the pool or put it to maintenance by simply executing a command through the Runtime API to have it withdrawn, deploy the code there, run some tests, and then if it's ready, it can lower the weight automatically, put the server to pool, see how it behaves with little traffic, and then gradually increase the weight of the server until it becomes equal to the rest of them, and then go to the next one. So both operational and administrative states can be changed. Operational are up, down, and administrative are drain maintenance already. So by changing the operational state, you can force the server to go down and then have health checks bring it back up if it's performing as it should. So one other thing that's very useful is that you can manipulate maps. Maps are key value stores inside of HAProxy. So for any fetch, any sample fetch that HAProxy can perform, you can look at any part of the request of the TCP/IP layer, or even the body of the request, and then you can match it against a map to get as a key to get some value, and then you can use this value in the configuration to perform any kind of request routing, maybe rewrites, even access control lists. What updating the maps without reloading allows you to do is to, for example, dynamically change the routing of the request depending on your deployment, depending on maybe some form of A/B testing, canary, anything that you can think of. So map entries, as I explained, which are actually key value entries, can be inspected, altered, edited, or removed. I think that this will be a lot more easy to grasp once I actually demonstrate what we're trying to do here. So going here to the configuration, we have very simple front end, which is going to be used to demo the map change. So it's bound to port 81, and it switches between a backend depending on the path of the request, and it matches it against a map stored in root direction map. So what we're expecting here is if the path matches something that's in this file, it will go either to backend 1 or to backend 2. Backend 1 is the web server 1, which is going to print the word 1 at the end, and backend 2 is the web server 2, which is going to print the word 2 at the end. So let me demonstrate this. So now if we go to port 81, we're going to see that it returns a 503. It returns a 503 because our path, which is just a slash, does not match anything in the direction map. Here we see that if we enter path 1, it should send us to backend 1. If we enter path 2, it should send us to backend 2. So let's try that. So you can see this always directs us to 1. This always directs us to 2. So here you can see that with show map, you can list all the maps loaded by HAProxy. In the configuration file, we have just this one map, which is loaded and used at line 53. So let's look at what is in this map. You can see here that this is the address where it's stored. You can see that the key is path 1 and the value is path 2. So let's say we want to change something. We want to say that if there is a path 3, it should go to backend number 2. So we can do this dynamically by just issuing a command. And now, as we have added, so what we have done is added to the map, which is referenced here, that path 3 should go to backend 2. If we look at the map now, you can see that we dynamically inserted a new value, which is path 3 goes to backend number 2. And just issuing this, we'll see that we always end up on 2. If the path is unknown, we still get a 503. This can, of course, be changed by the configuration. You can have a default backend, which we have omitted here on purpose. So if we go back to show map, we can also remove an entry. So we can do something like delete map, and now we should have deleted an entry with the key path1. So looking here, you can see that the path1 does not exist anymore. So this simply allows you to change the routing, change the rewrites, change anything that can be used with a key value storage on the fly without reloading the configuration. What the Runtime API also allows you to do is to manipulate ACLs. So ACLs are access control lists. Access control lists allow you to control the traffic passing through application delivery controller, be it with any condition from layer 7, like any of the headers, like maybe you want a host header, or maybe you have an authorization header that should have a specific value to allow your traffic to hit the backends. Or it can be used with even higher layers, lower layers like layer 3 or 4, or something in between like SSL information. And all of the manipulation can be done the same way as maps through the Runtime API. So this allows you to have a central place which controls all your blacklists, for example, or all your whitelists across all of your load balancers, and it dynamically changes them based on any external input. So let's look at an example of this. We can see here on this line, which is going to be this whole listen will be used later for another demo, but it's convenient here as well. So we see that we'll deny requests if the source matches whatever is listed in the file blacklist.list. So if we look at the file blacklist.list, it has just one range defined in it, and as we're using localhost anywhere, we actually don't hit this range. You will see that this demo is bound to port 82. So if we do this, we'll simply get what we used to get before. So let's see what ACLs are loaded into HAProxy. You can see that we're interested in this one, which is loaded from this file used at line 67. So we can either reference it by number, sorry, we can't reference it by number. We can reference it by name. So you can see that the show ACL root blacklist list will show us that at this address we have this one entry. Now, if we want to change this, we can simply add another entry to it. So let's block ourselves, for example. So instead of show ACL, I'll do add ACL to this ACL, and then we'll add localhost. If we do show ACL now, we will see that this new entry has been added and that we can no longer reach our backends. As we added a key, we can simply remove a key as well. And we can see that the key is successfully removed. So the API between ACLs and the maps is very similar, and you can use maps as ACLs, but ACLs, when used as ACLs, are more performant. So if you don't need a key value storage, you can simply use ACLs. If you need something that's a key and a value, then you can use maps. So this is pretty much what we have to talk about the ACLs and maps. And then there's a very convenient thing that HAProxy has, which is a generic key value store, which can be used to track clients, track information from the clients using any key that the client presents, like, for example, a source IP or a header or a specific fingerprint that you generate yourself. So they're called stick tables historically. They used to store stickiness information, but now are used for much more, including statistics and denial of service protection. And what the Runtime API can be used is to inspect this, as a lot of tools do, to export the statistics to an external tool for graphing, or they can be used to block or unblock a specific client based on any threshold that you set. So let's look at what I actually talked about now. So we define a stick table that stores IPs. Its size is 1 million rows. It expires in 1 hour. And what it stores is a per IP HTTP request rate during the past 60 seconds. And it has one general purpose counter. So the general purpose counter is going to be used later. Here, we tell it to track in the stick table that the key for tracking is the source IP of the request. And then here we say to deny the request if the general purpose counter number 0, which is stored in the table, referenced by SC0 in the parentheses, is bigger than 0. So I'll just do a 25 request to localhost port 82. Okay. Then I'm going to inspect what tables we have running in HAProxy. We have this one table. It says that its size is 1 million rows and that only one row is currently being used. The type of the table is IP because it stores IPs. So here we will see that our IP, which is localhost, currently does not have an active session, expires in this number of milliseconds. Its value of the general purpose counter 0 is 0, and the HTTP request rate over the past 60 seconds is 25, which is logical as I executed 25 requests. So here we can see that all this information and much more can be tracked per key in HAProxy fully during runtime without any performance penalty. Now, as I explained in the configuration, we say that if the value of the general purpose counter 0 for the source IP is bigger than 0, the request will be denied. We see here that the general purpose counter is not 0, and as such, our requests to port 82 will still be allowed. So some kind of an external tool or you yourself can dynamically change any value here, but for the purpose of this demonstration, we're going to change the value of the general purpose counter 0. So what you do is you just take the table name and you say that for the key, whatever the key is here, in our case, it's localhost, that the GPC 0 data should be 1. And you send this, to the Runtime API. And then if you look at the Runtime API and ask for the table, you will see that the value for the key has changed to 1. If I did everything correctly, we should see a blocked request here. So we can see that an external tool can easily change the behavior, can change any value, any tracked value of the load balancer dynamically without actually touching the configuration. So I hope this is pretty clear of what this can do with the right tooling around it and with the right integration with an orchestrator. So this I'm just going to explain. We're not going to do the demo because it's fairly complicated. So the TLS ticket keys, which are defined in RFC 5077, allow you to resume TLS sessions across multiple application delivery controllers easily. This is done by having the application delivery controller sign something called a ticket with a secret key, which is asymmetric key on the application delivery controller itself. And then this ticket is sent to the client encrypted and stored by the client. The client will then send this encrypted ticket back to the application delivery controller once it connects again. And by decrypting it, all the information about the TLS session, including the master key and stuff like that, is inside the ticket and can be reused without actually going through the full renegotiation process, which is quite expensive. The disadvantage of this process is that you can compromise perfect forward secrecy if you're not careful about how you store and use these keys that are used to sign the tickets, to encrypt the tickets. The best way to ensure that you minimize the chances of actually compromising perfect forward secrecy is to not store these keys on the file system, on the disk, but to store them in memory. So shared memory is fine for this, and that you rotate them periodically. There's different recommendations, but between 6, 12, 24 hours for each key is perfectly fine. Before this, once you rotated this key, you were supposed to reload your HAProxy process. But right now, this is not needed anymore, and you can rotate them through the Runtime API by simply echoing to set the TLS key to something. So to just quickly demonstrate this, these are the keys defined that are used in the configuration. So they're base 64 encoded 48-bit strings, bit keys, sorry. And the middle one is used for encryption and decryption. The one above and the one below are used for decryption. So you can examine this in the running HAProxy process by echoing show TLS keys into the Runtime API. You can see that only one file is loaded, and you can see the exact keys by adding the file parameter. And now we can generate a new key. And we can set this new key into this runtime environment and have HAProxy rotate the keys like this. So we'll do this by echoing set TLS keys, then the file name from which the keys are loaded, and then the key. Oops. Okay, I have to have missed the exact command, but it's I think I'm missing SSL here. Yep. Okay, so I'm missing SSL, and then you should see that this key has been updated and rotated. So the first key disappears, which is normal because that's the old key. The key that was used for encryption and decryption is moved to be only a decryption key. The last one that was added is now becoming the encryption and decryption key, and the new one is added as the decryption key. So this is how HAProxy automatically rotates the TLS ticket keys by using the Runtime API. Nice. You can also use the Runtime API to troubleshoot. So the Runtime API exposed a lot of information, as we've seen before, using the show info, the show stats, but there is also some other stuff like show errors. Show errors is a very convenient command that will allow you to inspect any errors in the protocol level of HTTP. So if, for example, you have a client that has sent a request and complains to you that he's getting a bad request response from HAProxy, you can simply use the Runtime API to ask HAProxy to show you the errors generated for each frontend and backend, and HAProxy will store this information for the last request that errored out, and will show you the exact position of the character that does not conform to the HTTP specification. And then there's other commands that can be used if you're submitting a bug report, or if you simply want to inspect the state of your HAProxy, is something like the show ses, which shows the sessions and a lot of information about their internal structures. There's also show FDs, which is used by the developers to understand which state the file descriptors are in. There's show pools that allow you to examine the internal memory pools of HAProxy and see where the memory is being maybe leaked, or where you have a lot of memory being used by HAProxy. How many pools are allocated, how many slots in the pool are currently in use. So all this information can be extracted by the Runtime API and can aid our teams in investigating bugs, can aid you in understanding where your memory is used, or why our sessions are open for as long as they are. And with this, we have reached the end of our presentation. So I'm going to hand it over to Tim.
Thanks, Nenad. So we have a few questions coming in here, but first let me just say that any of the things that Nenad showed here as far as Runtime API is going to be available in both the Community Edition and Enterprise Edition of HAProxy, so you can download the Community Edition from haproxy.org, and you can get a trial of the Enterprise Edition with the configuration API that Nenad mentioned earlier from haproxy.com. So a few questions that we've got to start off with. One is based on the unified API that you mentioned earlier, Nenad. When do you think we'll be planning on releasing that?
Sorry, I was muted. So there is no definite release date, but we're looking somewhere early next year. So somewhere early 2018, we should have something available for people to test out and to give their suggestions on any improvements that can be made.
Cool. Another question about a feature support here is, are we planning at any point to natively support HashiCorp console?
So we do plan on, in terms of natively, we're not sure if it's going to be in HAProxy, but we're going to definitely have a component that can sit alongside HAProxy that will pull console's API and use what we described here to populate the backends. But there is also a way of using console's DNS interface, which is natively supported by HAProxy with the 1.8 release and the upcoming Enterprise Edition.
Great. Another question here about support for other technologies. Are there plans to support dynamic management of SSL certificates at any point?
So this has not been discussed at all. So I can't say if it is or if it's not. It's a new feature request. So if you can describe your use case and send it to the email specified here, we would love to hear about it and investigate on how we can make this happen.
Definitely. Another one here. Do we plan on supporting adding listeners through runtime?
No, because the listeners usually require you to bind to a specific port, and oftentimes this port is from a privileged port range. So by supporting this, we would have to have HAProxy running as root, which is something that you do not want your load balancer to do. Even though we have a perfect track record of security, it's still something that we discourage. The reloads being hitless really does not prevent us from reloading if we need to bind new listeners. So we prefer to keep it this way.
Sounds good. Okay, how about support for Let's Encrypt?
So there is a lot of components available already that support Let's Encrypt for HAProxy, including some Lua modules. We're definitely looking into making it more native, but it's not something that's very high on our priority list, given that it already works with HAProxy.
Excellent. Another question here. Where can I find the explanation of all the fields in the show stat output?
So the fields in the show stat output are all explained in the management document available on our website. So it's a part of the documentation. They're added there as they're added to the API, so it's perfectly up to date, and you can read the description of any field. And if anything is unclear, you think that any field could use some better description, or even if you find something missing, which is highly unlikely in my opinion, please submit an email to our mailing list and explain what you find that's not so clear as it could be, or you don't understand, or there is even something missing.
Great. All right. Another question: are location insights available, as in geo possibly being tasked to provide data and influence applications?
Can you please repeat the question? I did not.
Yeah, sure. Let me slow that one down for you. Are location insights available, as in geo possibly being tasked to provide data and influence applications?
So in terms of, so you can load anything as a map. This includes geo information about the client. So you can use, I do not want to name the companies, but there's a bunch of the companies providing geo information based on the source IP. So all this information can be loaded in HAProxy. We have converters for the top ones where you convert their format to the map file, load the map file inside HAProxy, and then HAProxy can do whatever you want based on the geo information of the client, including sending traffic to a different backend, blocking traffic from specific countries or ISPs or anything else that you might want to do.
Awesome. Yep. Just one last question here that I'll take. Will this be available as a recording, and if so, when? We have recorded today's session, and we'll be putting it up within the next day or so. And as Nenad mentioned earlier, if you do have any feature requests or if you have any questions, you can send it to team@haproxy.com, and we can get those into the right hands. If you want to schedule a demo for HAProxy Enterprise Edition at any point, you can absolutely contact us about that as well, or download the trial directly from haproxy.com. Nenad, thanks for the presentation today. Thanks for the demo. Thanks for answering all the questions. Thank you to everyone for attending and providing your questions. And we'll see you next time. Thanks.
Thank you.